Hey everyone, how are we doing? We'll start over here. Nathaniel has a quick question right here. So let me hop into the main screen. I'm gonna do Nathaniel's question, then we'll hop to Trace's and then Lillian's. Let's do this. So for 475, make sure you have an instructions.rmd app. So you need to create a markdown file, but very importantly right here, you have everything in your working directory. I've worked with a few people on this. Please get a hold of me if you have issues right here. But one of the big things about working with R is that everything needs to be in the same directory. So make sure you have your instruction.rmd file, which is the instruction.rmd file, in the same directory. So have everything in the same directory. Big thing right there. If they're not all in the same directory, not going to work. So check that out. Get a hold of me if you can't get it working. Earlier the better. Little errors can turn into big problems. No! I got my new coffee. Trace has a question about number 4. Let's go take a look at number 4 right here. Wondering about the return. So I'm going to go grab the homework assignment. Got my coffee. How is everyone doing right here? Mubot, let's re-wake up Mubot. Mubot needs to re-awake. And we'll re-wake up Mubot. Mubot's waking back up. Go back here to some 474. Go over to assignments. Conditionals turned in. So many assignments. Let's go over to functions. We will post some keys coming up here soon. Oh, gonna hit my elbow on the desk. Homework 5, halfway done with homework assignments. I like it. So Trace's question is over. You're welcome, Nathaniel, anytime. Trace's question is over. Number 4 wants to know the second check. Do you want us to output it as NA, or do you need this right here? Let's go look at number 4 for 474. Here we go. This is number 4 for 474 right here. Going down to question number 4. Write a function called Spannage, which is going to get you the span of a vector. That takes 3 arguments. X is going to be a vector of numeric values. N is going to be an integer. And remove NA defaults to false. Kind of like that remove NAs, in the mean thing. This argument determines how missing values are handled. If remove NA is true, any NAs, which are missing this, should be removed, i.e. via, we can use X save into a vector that does not have missingness. Just so you can see what happens right here. If we do X and we do NA.omit, you should see how these things work right here. We have a vector with missingness, and then we store, and what do we get in X? X is going to here, and it has attributes which are kind of like pinned on things to a vector. They're not the numbers themselves, but we get right here a vector right here of 3 and 4. So we get right here these vectors, and it omitted positions 1 and 2, and we can confirm this. If we go back here and put in something like 10, and we can see what we get for vector x now, we see we get the vector here, and then the omitted value was in position 2, so it's omitting value 2. This still can just be used as a vector, like we can go to the mean of x, and you can still just get the mean. Attributes are just like pins on a vector. They're just additional things that give you information about something that happened to this. It's like a story of the vector. So we get to continue on a little bit with the story. So if NA removes is false, it's not going to do that. Almost like an if right here. Like if NA remove is equal to false, it's not going to do that. Should be left as is. The function should find the difference between the nth largest value of a vector and the nth smallest value of a vector, then divide that difference by the mean of the vector. So an important step right here is to think about the equation you're writing for this portion. For this portion right here, you want to think, okay, I need to find a vector. How would you, don't put it fully in the chat, but how would you maybe figure out where a certain element of a vector is? How could you find out, and this is a huge hint because we have to do this in steps. We have to be like, okay, what's this wanting? How could you maybe figure out where certain things are in a vector? Well, people think that over here in a moment for 474, and then we'll do, was it Lillian's question next? How could we, the answer is not order. How could we put things in order for a vector? How could we find out certain order for a vector, like the smaller numbers, the larger numbers? How could we, I don't want the full code. I just want like the function we'd use. How could we find out a certain, the answer is not order. How could we find out a certain order for a vector? As we want to find the smaller things or we want to find the bigger things. We're like, okay, we need to get this vector in a certain format. Sort right there, Braden. Great job. We want to sort the vector 20 points right there in the chat. we want to sort the vector. And sorting the vector is going to put it in an order. Now, order is a different thing. It tells us the order by which we need to return data sets. Like, oh, sorry, exactly. So we can sort the vector, and probably people are doing this. Like, you could, do decreasing true, decreasing false, and then you could, pull out the certain elements, like the first or the second, when you choose which way to sort it. Like, you either sort it this way or you sort it this way. So Rfast too. Oh, Rfast? Is there a function Rfast? Wait, maybe there is. I don't know what it is. If there is, there's a function I don't know, or I don't know what's going on. So we have right here a vector, and n is 2. The second largest value is 6. The smallest is 2. The mean is 4. And then we're just going to divide by. So it's just showing you here a sorted vector. So hint, get your vector sorted, and then worry about getting the larger or small. Oh, it's the Rfast, is it? I'll check it out here in a moment. We'll do that after Lillian's. I want to actually check that out. I might try to do it a little bit with this here. Once your function is written, I'll comment the 4 grid lines so the output is knitted. And I think we don't show the output. With the Spannage function right here, are you talking about with this one right here? I think you're talking about the second one, right, Trace? Trace was asking about... So I believe for this one right here, because there is NAs in here, you will get NAs. So without the NA remove equals true, you will get NA as a return. So you will get NA as a return. Let me see here. Yeah. That's probably why right there, because when it does the mean, you're getting, it's going to divide by an NA. So the reason you're getting NAs is because, well, yeah, and if you notice right here, this just shows it works right here on this one, because this doesn't have any NAs. So you should get the difference between... we could theoretically find out the answer to this. Here, I'm not going to write the function, but the theoretical answer for this one is going to be the following. Let's go here to sort, and this is a good hint for the assignment. It's going to be this number, and then you could kind of reverse it. There's a lot of ways to reverse this. You could use the argument, or you could rev. People might know this, but there's a function rev inside of R. It stands for reverse, just reverses a vector. So the answer for this, we can confirm our answer. The biggest minus the smallest. Which one is this? Big minus small. Big number minus small number. If we do the fourth, which this is, so Trace, are you getting the following value for this? And this is a good way to confirm your answer. Empty cars, MPG. Is that what you get for the first answer? The first answer should be that, theoretically speaking, because that is the fourth largest value, 1, 2, 3, 4, and that is the fourth smallest value, 1, 2, 3, 4, 14.3. I did get it. And then we are dividing by the mean of it. So this is the fourth largest. So this does confirm the answer right here. Good validation check. It also shows a little bit of the formula. Now, I didn't have it go through and algorithmically find these. This is the value by which we're changing for this argument. But you want to try to write this out. Like, try using this one maybe as the context. And you can sort a vector. You can reverse it. Rfast, what is it's Rfast package? Here, we'll take a look. We'll do that after Lillian's question. Thank you so much, Lillian, for waiting. So that's a little bit of help. So Trace, if you're getting an A for this second one right here, you're doing it right. This one you should not get NAs on, because your argument is going to take the true right here and omit the NAs. So you will get the NA omit from that vector, and you won't get an NA anymore. If you get an A on this one, you're having a bad time. If you get an A on this one, you probably did it right. Probably. I can't promise, because the other ones would confirm also. Let's hop back to space and work on Lillian's question. Great job, everybody. More coffee, more coffee, more coffee. I might work on a new logo, like statue one, like spins on the screen and goes like, and opens a window to a new world. Be kind of cool. I have the idea and then got to make it happen. Okay, so Lillian's question is, hey, what's up, Cliff? Good to see you here. Lillian's question is, could you go over Q2 on 474 homework? Let's talk about some Q2 474. Q2 474. Let's take a look. We should label the chunks. Write a function called cumulative sum that takes an argument, a numeric vector x. It's going to take 1. This function returns a vector of the same length of x. The ith element of the vector is the sum of the first, the second, the ith elements of the inputs of x. In other words, the return vector, its first element, is the first element. The second element is the sum of the first and the second element. And so we think theoretically what this is going to be. Let's first think theoretically on this. What is the return for the cumulative sum? Would be... So if we were to run cumulative sum on something, we were to run it on this, what would be the cumulative sum of this right here? Who knows the answer to this? 20 points in the chat. If we were to run it on this, what would the answer to this be? And then we'll go one step further on this. Might work a good bit of this one. I don't mind doing one problem during office hours. Might work this one. Might work this one. We talked a good bit theory the last one. So if we were to run cumulative sum on this, what would the return be? And then we have to think about how that's made. What would the return of this be? He says, trust me, I'm a doctor. He's a dog and he's a doctor. That's cool. That's your meme of the day. It's not really a meme. 1 and 9, you are correct. That would be the cumulative sum. Great job right there, Braden. 20 points in the chat. I still got those 20 points. It'd be 1 and 9 because the first element is just the sum of the first element. The second element is the sum of the first and the second. Now get ready. Things are about to get crazy. What is the cumulative sum vector return now? So it's still going to stay the same for the first two elements. You could just tell me the last element or maybe tell me the full vector return. But we're going to get a vector length of 3. So 3 elements in the vector. And you can tell me what they all will be, but if you append onto it, I'll know. After Rfast, and Lillian, could you tell me? Yeah, I'll take a look. We'll do Rfast here next. You got it, Trace. Definitely. Thank you, Trace. So, just shows the output of the petition earlier. Yeah, let's look at that. You're returning the NA omit position true. You might send me your code in Discord. This might be like a code specific thing. So what would the new return of the cumulative sum be right here? What would the new cumulative sum return right here? Any ideas? Right now we have 1, 8, 11. So if we do a cumulative sum of this, and the way it does is it gets the first element, just returns that, goes to the second element, the sum of the first and the second. That's the second element now. The third element is the sum of the first, the second, the third. So we just found out that previously it was 1 and 9 before we added on 11. But now that we add on 11, we're going to have a length return of 3. Lillian, excellent work right there. We are going to get a return of that. So let's work with this right here and just see if we can get it to work on this vector first, and then we'll turn it into a function. So remember, when you write functions, don't start by writing your full function. Get it to work on this. So this is our vector x right here, which we'll take as an input. Now, when we do this, the first element of x is simply going to be, no eyes yet. The first element is simply going to be the first element. Let's go here and call it, let's call it answer. I like to call things answer sometimes. Oh, we have no answer vector. Create the answer vector. Now we can do it. Is this making sense what I've done right here? Because every time we do this, the first thing for the answer is going to be the first thing that's in X. It doesn't matter. It doesn't matter. I need that right there. I need to get that on my soundboard. Ask The Rock what he thinks about it and be like, it doesn't matter. I don't know. That might be fun. So right here we see we need to vote. It's like, what does Brian need on his soundboard? It can only be positive stuff. Rock's positive. He throws out a bunch of positivity. So Rock could make it on the soundboard. I'm cool with that. So what do we see right here? The first element of the answer will always be the first element of X. Is this making logical sense that this will never change? This will always be this way. Who's with me on this? Makes sense? I think we're good on that. It's always going to be the first thing. Great job, Lillian, right there. Excellent work. Some 20 points. Earn all the points during office hours. So then the second element is where things get a little bit interesting. A little bit interesting. The second element needs to be the what. And there's some good ways to write this. The second element needs to be the what. There's a few. I want someone to write it one way. You might write it the easy way or the way that'll really work. There's the way of writing it that's here. I'll write it the bad way. It's not a bad way, but it's a way that's going to be a lot harder to work with than the way I'm going to write it after this. We have 3 elements right now. You can see it's going to become an iterative process right here. And this can be worked with, but we're not really going to be able to turn this into a function because how often I have to iterate through doesn't really make sense. Or you could go to the previous element. There's some ways of handling this. I have a way, I'm going to handle it here in a moment, that I think may work better. Really, when you look at this, can anyone tell me a better way of saying 1 through 3? I mean, I'm saying it. I know, right? That's not that fun right there. Oh gosh, that looks crazy, Trace. I like that. How can we say 1 through 3 a lot quicker way than doing this right here? And what are we doing to 1 through 3? Just think, we're doing this to 1 through 3. There you go, Aaron. Excellent work right there. Great job, Aaron. And Lillian. Excellent work. Trace, Aaron, Lillian. Great job during practice during office hours. What do you think I want to do? Who can see where I'm going with this? Who can see where I'm going that I'm like, brain's right, we're summing them up. We want to take what's in X in positions 1 through 3 and sum them up. So you're figuring it out right there. We want to take what is in X in positions 1 through 3 and sum them up. So what do you think I'm going to write right here? Which there's other ways to do this, but I think this is going to be one of the better ways. I want to take what's in X positions 1 through 3 and sum them up. So I want to take what's in X positions 1 through 3 and sum them up. Right there, Trace is getting it right there. Trace has, we are going to go to X position 1 through 3, and we are then going to take the sum of those, and look at that. Much better, much more concise, and in truth, we could recode this one to just that. So now we're getting somewhere. So let's look at the answer. Now we're getting somewhere. That was the answer we said we should have, right? I changed it slightly just to see the previous example from earlier on. This is the answer we said we should have. And I think Lillian's seeing it also. Great job, Lillian. What did we just create? Say it in the chat. Say in the chat, we just created the what? You know what I'm talking about. Someone random's watching this. Maybe our Bulgarian friend. Maybe Calzone's here today. He came in during their Kahoot. He loves those Kahoots. Someone's like, what are you talking about? You're what? But if you're in my class and you see me doing this, you know we just built the what. You know it right there in chat for 20 points. We just built our what? The thing that repeats, that is always the same. Lillian, you're right, the skeleton. We built our skeleton. The skeleton is the code that's inside the for loop that repeats endlessly. So we need to go here to for, and we have our for loop. Now, we don't want it to store into 2 first. We want it to technically store into I. And I'm going to put 1 here because that's where it starts. So I will start at 1. I'll call it I. And this is what changes. Notice how this changes. That's the placeholder that changes. And then the vector are the elements it'll go through. Now, mine goes through 1 through 3 right now, but what in truth are we doing? We're not going through 1 through 3. We're actually going through, not 1 through 11, we're actually going through 1 through the what of X. So we're not going through 1 through 3, but we are going through 1 through 3, because right now it is 3, but we're going through 1 through what of X. It's how many things are in X. It's the what of X. Because we need to say keep going if X has more elements in it. How can we find the elements of X? Start at 1 and go up to the number that is the length of the X. Great job right there, Aaron. So we're going to go through the length of X. And once again, we want to make sure this works. Always check your work along the way to make sure what you're getting is true. I always say to people, watch how many times I check my answers. And that's how I've learned to not make mistakes, is to check what I get. Great job, Lillian and Aaron right there. We're going through 1 through the length of X. You know what? We're basically there. I think we've done it. Trying to think what else there is. We got some cumulative sums right here. This is going to be 1, 2, 3, 4, -1, 0, 2, 5, right? So we need to call our function cumulative sum. To do this, we're just going to do our favorite song. F is for friends who do stuff together. U is for you and me. N is for anywhere and anytime at all. Keep using snippets to make life easy. Horrible rhyme at the end. So at this right here, we're going to call it cumulative sum. That's what the function is going to be stored into. Use the snippets, makes life easy. We're going to grab right here. We need to create the answer vector inside of here. So that way it has something to store into. We're going to re-indent our lines just to make it look all pretty. Let's go right here and go to re-indent code lines. A little bit better. Okay, I like that a little bit better. Doesn't matter how it looks. Still works. We only need to change something though. What does our code take to work? We need 2 changes. 2 changes. 20 points each. 2 changes. My code missing some stuff right here. 2 changes to make this work. 2 changes. 2 things. 2 things. What are 2 things I need? My code has no argument right now. It takes variables. Well, yeah, I mean, I need to put something there, though. We're really close. And then my code doesn't return anything. Everything stays in Vegas. Specify an argument. The argument name we are going to use is going to be not answer, but X. Whatever goes into here, remember we were working with X to begin with. So X is what passes through here. Does that make sense? Like X is what we give it, and then it finds out this for X right here. That's why we decided to go for 1 through the length of X, because the length of X might not be consistent. If you hard code in 3, you'll only get the cumulative sum up to 3. So we didn't hard code 3 in there. We allowed it to go through the length and trace. Great job, everyone. Amazing work today during office hours. I like doing questions like this when we can all practice it and follow along. That's when you get me psyched and we start to maybe do some more questions. You never know. I'm not saying I'm going to stop office hours, but you never know. Like, Brad, make me do a little question here. You done that question? Boom, question done. Boom, question done. Confirm your answers. Cumulative sum means we're adding together each element, as in -1 is -1. -1 plus 1 is 0. Now we're at 0. 0 plus 2 is 2. Now we're at 2. 2 plus 3 is 5. For the previous one, 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Math is hard. 3 plus 1 is 4. And there we go. So just following these steps, maybe you've worked this question, but I would probably delete this work. You might go right here. Control-Shift-C is bulk comment, or what is it called? There's a bulk comment, or a block comment. That's what it's called, block comment. That's the technical lingo for it. That was Control-Shift-C, a really quick way to comment out a bunch of code, because I really don't need that right there. One thing you can also do is double check to make sure your stuff works. If you want to double check to make sure what you've created works, clear your global environment, and then run your code. Probably run your chunk, and then if you get the answers, which it looks like we got, we're good. That's a good way to ensure what you have will knit, because sometimes you have something in your global environment which is helping you knit, and when you knit, something you may not know, is R starts a fresh session. So unless what you have is in your document, R won't be able to knit it. So if you ever want to see if your documents will knit, you can go here, remove everything in the global environment, start at the very beginning, and start running your code. And that'll also show you where it crashes. We should maybe, I don't know, it's just something that you learn over time, like finding those crashes, finding out what's wrong. And if you have something that just won't knit, going out to everyone right here, if something won't knit, you say, go away. You won't knit, you get out of here. Go home. Well, that's got it. I think we'll hop to Rfast. Let's hop back here to space. I can't even speak today. New time, new space. Let's do this. Rfast. Is Rfast the package? Sounds like Rfast. Do I have I don't have Rfast right now. Is Rfast the package? Is it? Installed a pack? I think I've heard of it. Ooh. Perhaps meant capital Rfast. Perhaps I did. Or perhaps you're smarter than me. Did someone like put that? We're going to go look at some library Rfast here. Please ask questions if you have it. It's kind of open floor on questions right now. We're 23 minutes in. Open floor on questions. No package Rfast because I didn't capitalize it. Capital Rfast. Okay. Let's go take a look at some Rfast. So on the 475 midterm for number 7, are we just interpreting the performance of 1 or 2 basics? Use accuracy. Yeah. Maybe have it maybe have it shift between whichever model you're picking. You kind of want something where you could put an accuracy page for each model, but your real best way of doing it is that when you reactively create the accuracy, it could then take the accuracy and you could look at maybe a model selected. So, as I think about how to design this, you could have a drop-down menu picking which type of model you're creating. You get one model page. You have individual model pages. If I'm designing this, I might just do selection method for model and then analysis page. So there's a million ways to do it. It's all about you. It's all about how you want to do it. Can you send send me your RMD, Trace. Might look at it in the background here. We can do that next. Trace, send me that RMD. We'll take a look. Let's look at this Rfast package. Have I used this before? Can't remember if I used Rfast. Ooh, it's a big package. Got a lot of stuff in it. Ooh, got some BIC, some Bayesian information criteria, it looks like. Some AIC, some AUC, some area under the curve. So we're looking at model metrics right here. I swear I've used Rfast. Every time I reinstall R, I lose my packages. Oh, we got all betas for models, maybe. Check names, check alias. So colonovas, Cume products, columns. These are column functions right here. Call means, yeah, call means. I've used call means. Is there two call means functions? I've used call means. It's a base R function. Yeah, it's a base R function. I know I've used call means before. Got Weibold. Variance. This is, yeah, I swear I've used Rfast. T-test. You got multiple t-tests right here. Let's read the documentation on those. Paired t-test. Two-way ANOVAs. Oh my gosh. Rfast is a ridiculous package. Yeah, if you have questions. So check out Rfast. Yeah, this has about every Rbing. But yeah, check out Rfast. I didn't know the Poisson distribution. Permutation. It's got permutation methods in here. This is insanity. I sent to you. Awesome. We'll check that here. Trace. Logistics stuff. K nearest neighbors. James is even here. We got James. I mean, come on. If we shout outs to James right there. Give him some shout outs. So, beta. I don't even know. Hash. Some of these I know what they are. Some of them is GLM, so generalized linear models with logistic and Poisson geometric. Let's hop over here. I'm going to take a look at Trace's work right here, but this is a amazing package. I'm pretty sure I've used it. Just don't have it downloaded. You got an exact test, Fisher exact test, it looks like, for t-tests. Fisher, some stuff by Ronald Fisher right there. Just, yeah, everyone's got to put their name on something. Nothing wrong with that. They earned it. They made it. Let's go back to space. Sometimes I just have a little bit of fun looking at these packages and seeing what's in here. We got Floyd in there. I don't even know. Distance, that's good for, no wonder. It's got K nearest neighbors, it's got distance metrics. So, yeah. I've used Rfast. I know I have. Just haven't put it on here lately. Let's go take a look. I'm going to take a look at Trace's work right here. Trace, let me take a look. Oh, nice. I think Kayla got something figured out. Okay, you're looking at number 3. Let me go look at number 3 right here. I just find it relaxing to look at packages and see, like, what's inside them and what do they do. Number 3, the which function. Wait, let's code the which function. Write a function called mywhich. You're looking at an input x vector as a vector of logical conditions to return the positions of the trues. So I'm going to take a look at your... Oh, you've got it commented out. Wait, here we go. So what was your question? Let me hop back to the chat and take a look. What were you wondering about specifically, Trace? Okay, I sent to you. I am curious, is na.omit can be accepted? Na.omit gives the positions, but gives a bit more output than just which. You should be all right. Because, let me check your function. Let me check your mywhich function. The way you know this works, if it works the same... Oh, and I see what you're saying. You know what you could do? I have an idea here, Trace. Because you're saying because it gives more output, right? If the grader would, I wouldn't mind if the grader took... I mean, the grader shouldn't take off. I don't mind this. I'm seeing where in your code it does this. Oh, there it is. You got the na.omit on it. Let me... what we need to do is we need to remove attributes. Remove attributes in R. So we're going to remove the attributes. To go remove. It's just remove attributes. That's might be it. Remove attributes. No, it says that's a code. Underscore attributes. How can it say that that's a code and not be a code? Is it in a package that I do not have? Let me see right here. How to erase all attributes. Oof, that's a lot of work. Oh, that's not fun. I just want to remove it in one vector. They're L applying. They're storing into attributes null. Okay, so they're writing. Okay, so they're writing into the attributes of X. So here, I'll show this. I might just show this in a moment here. So you're NA omitting on position true, and you're getting the positions of true. We'll go outside here, outside the loop. When you run this, we'll just run right here, and we'll store this as position true. I might just show this, and I think this will work. And if we store that here, and then we go to the attributes of position true, and we null them out, which destroys things. And we took the NA omit right here. I'll show you this in 2 seconds here, Trace. I'm gonna see if it works, and then I'll show you what I added to it. I'll zoom in on it so you other people only see this part. Got it. Okay, good. Okay, I'm gonna zoom in on this, Trace, so you can see what I changed. And okay, so here we go, Trace. Take a look. I'll show you what I did to the code, and this will maybe help out other people here a little bit to see this. Put on a little chill music as we do. Here you go, Trace. Take a look at this right here. Okay, so this goes, once again, to a little bit of our coding knowledge of what we got right here. I took what you were doing right here because you were using the NA omit down here. If you notice, my output now does not have the attributes. Not the end of the world that has attributes. Like, if someone lost points and they said, hey, Brian, I lost points. Can I get my points back? I'd say, yeah, sure. It's whatever. It's got attributes. But I did a storage, and I just wrote into position true the NA omit of position true. That's where the attributes are coming into play. But then I added a line of code right here, attributes, save into the attributes, which are just a thing that exists. Like, I just call them like ribbons on a vector. Like, it's still just a numeric vector. It's just got extra like, hey, here's a story about the vector. Now we're just deleting its story. This vector has no story. It's just a vector again. And you can see that down here when I run the returns, the vector does not have its attributes anymore. And this is because I went to the attributes portion of it, which are the things like pinned onto it. And I said, you lose your story right here. Go away. Story's been nulled out. Story no longer exists. And so this just nulls out this portion because this calls the attributes. Then we destroy the attributes, and then we just call the vector. Does that make sense here, Trace? Just what I've done right here. Your code was more concise in this area. It just had the just had this right here in this area. So I took that out, just stored it right here for the moment, removed its attributes, and then just returned it. So hopefully that makes sense right there. There's the little small changes. It would be totally fine either way. But just going to the attributes vector, what I was looking up on Stack Overflow, someone was doing it over a data frame, so they were L applying it, which makes sense too. If you have a data frame with vectors, data frames can be considered lists, and we saw it earlier on. Yep. It does make sense, a lot of sense. Yeah. Exactly. Yeah, you can remove attributes. It's like pins. Ah. My teeth. Can't wait to get my real teeth. One day I'll be a real boy again. But awesome stuff right there. Hey, what's up, Kayla? We're just messing around with the attributes right here. I saw you got it working on Discord. I hopped over to answer Trace's question. If you have questions right now, it's open floor for questions. Open floor for questions. Yeah, you could do complete cases. There's so many ways to do this. So many cool ways to do this. And I do like seeing the differences among the ways and kind of these small improvements. And once again, you just got to start early. You got to get stuck. You got to say, hey, can you fix this? And I'm always up for fixing these small things. So, just start small. Work with a vector like we did. We did an earlier question. We'll hop back to your spice. It is open floor on questions. Could you show how to start Q3? Yeah, this is Q3, right? Let me take a look, and we'll show how to start right here. Let me get some Q3 up and going. Q3, doing the My Witch. Sounds like a witch. I've never been to that place. Okay. Okay, let's talk about some Q3. I might not do the whole thing here. Let's go talk about some Q3. Really want to make that new thing. It'd be really fun. Just so many cool ideas. Okay. So with Q3 right here, we're basically writing our own which function. You can't just take the which function and do it, though. You can't take the which function and do it. What we're trying to do, if you look down here at the code, is we have a vector x, and you can tell how which works. How much... How much wood would a woodchuck chuck if a woodchuck could chuck wood? He would chuck, he would. Andrew Wynn is definitely the best. Isn't that right, Mubot?
That's totally right.
Mebot's always here. So you can see how the which function works, but we want our function to work this way. It's 700 pounds on turn today. And so when we do this right here, let's take this vector of x to begin with. And just think about this theoretically right here. The problem has some really good instructions walking through it. And what we want to do is we want to evaluate. We want to evaluate first off if x is greater than whatever the input value somebody put in. So we need right here for it to take a logical statement. So right now, we're just going to go right here. And let's say we have a logical. Let's just say we're working with a logical statement of true, false, true, true. Can anyone tell me what the which should return right here? Because this is what our function will take. It'll take a logical. So let's just say logical. What will our function take? Or what will our function return if I were to run which on this? Just looking at this, this is a logical statement, which we're just basically talking about. Right here, our function is just going to take a logical. You can call it logical, you can call it x, whatever you want, but that's what our function is going to take. And then what would the return on this be? Be very careful. Very careful. Don't worry, 20 points right there, everybody. Exactly, remember which returns the positions of the true. If you sum it, it'll return 3 because there's 3 trues, but it'll return 1, 3, 4 because which tells us where the trues are at, like which ones are true. So which says which ones are true. Good practice right there. Practice, practice. Don't worry. Get the skills up. And so with this right here, we're going to go and start writing the function right here. So into it, yep. So let's see right here and think about how to do this. Look at their logic a little bit here. So first off, we've got the check for the class. Well, first off, we can write that. Let's go ahead and think about this and say if class of whatever logical is, if we knew how to spell, class of logical, so as we put things with very close spellings, is not, and then I think it needs to be, let's find out how to spell it. Lowercase, come on, R, capitalize your spelling. Okay. Let's just go right here and say, hello. Now, what will this code do? I'm currently giving it a logical. I am currently giving this a logical. I am currently giving this a logical. So what will this code do? Decent test question here. Like if you saw this together, there's a logical vector stored into here. It says if class of logical, which it is logical, not trying to trick you there, is not equal to logical, say hello. What will this code do? Which is what I want it to do. I'll change it from saying hello in a moment. What will this code do? Code on line 126 will do absolutely. I think it evaluates to false in the if. It should do absolutely. I always know what your code's going to do. Absolutely nothing. Nothing. Why is it doing nothing? Why is the code doing nothing? I'm asking, good job, 20 points right there, Andrew. I'm asking if the class of logical is not equal to logical. Great job, Lillian, right there. 40 points. Let's up the points. If the class of logical is not equal to logical, if that is a true statement, if we have not given this a logical vector, it'll say hello, which will put in another error message there. I might not code your error message for you, but if the class of logical is not equal to logical, which that's a false statement, because this is a logical right now, exactly, Andrew, right here, because this is a logical, this evaluates to false, because it is false that is not a logical. Does that make sense? It's a little bit of like double negatives there. It is false that it is not a logical. But that's how we're evaluating this, because we're asking, did someone feed us not a logical thing? And you're like, no, that's not true. That's false. It is false that they did not feed us a logical. A logical is something that is trues and falses inside of R. They're like Booleans right here, trues and falses. So that's not the word true and false. That is the special character true, which is seen as ones and zeros inside of R, but they're handled as logical ideas. And so we can change that there later on, but that's a good part of this function to think about. Now, looking at the next part that they have pre-written for us, going right here, this is just the code that runs. So we've actually completed this right here. It's too much help. Find the position of true. So here we're finding the positions of the true, and we're creating a blank vector. So the first thing to do whenever you're about to for loop is to go through and create a blank vector to store things into, if you're going to store things. So when we do our for loop right here, how many instances do we work on when we work on our for loop? And I'll probably stop it here once we do the, how many instances do we work on? Yeah, good job right there, Andrew. How many instances do we work on when we write a for loop to begin with? So practicing writing your for loop here, which is a big thing, how many instances do you work on when you're writing a for loop? How many times do you get the for loop to work, which is the major thing we need to do? So many people just jump into, I'm going to write a for loop, I'm doing it, and I'm my skeleton, and I don't know what my variable is. It's Brian, and I'm going here 1 through 100. I don't know what I'm doing. How many instances do we get our for loop to work on before we write for? How many instances do we get our for loop to work on before we start writing our for loop? How many instances do we get our for loop to work on? Before we start writing that for loop, how many instances do we get to work on? 1 instance. I don't follow this all the time. I break the rules, and then I pay for it. And then I'm like, it won't work. And then I'm like, I just got to do it in the way I tell my students to do it. I teach how to do this, and then I don't do what I tell people to do, and then I pay the consequences. Okay, let's go take a look at this. We've got here a logical vector. And since we fed this a logical vector, we could go right here and we can check the first instance of the logical. And what you could do, you could use an if. I'm just trying to think of a nice way to do this. I guess. Just think of the nicest way to do it. Did you say you used complete cases? Yeah, you could do it with complete cases too. So this is, we're looking at logical position 1. Someone did feed this a logical vector into our my_which. So somebody fed us a logical, this returns true. And so you could say we don't even need to do an equals equals, because equals equals true is just, I used to do this all the time. But equals equals true does true equals equals true. That is true. We are back. Stream issue reconnecting. Sorry about that. We've been good this week. Random disconnect, reconnect. So I don't think we suggest the if way of doing it. So right here, I have like 2 ways of doing it, and I'm between it. And I don't want to write the for loop for it. We just want to, 2 wrongs don't make it right. 2 rights. That is true. 2 Wright brothers did make the plane. So we're going to go here. And the positions of the true are going to be based on this. In this position right here. Yeah, I see which. And then we can do the NA and emit on it. Yeah. Yeah. That's the way to do it. So if the logical, which is true or false, so actually we could write it like this. We don't want to store. No, we can probably do this. This should work, theoretically. Everyone's going to do this now. No, we don't want to store true. We want to store the position number. And then else NA. Okay, let's go look at what we created. Cool. It worked. What is Brian doing right now? Good. It works. Done. Problem's basically pretty much done from here. What am I doing? I don't want to show you what I want to. You should know what I'm going to change. You should know what that 1 and 2, someone can put in the chat what 1, 2, and 3 are going to become. Someone should know what 1, 2, and 3 are going to become right here. It's showing which positions, not which positions are false. I mean, technically, excuse me. Technically, the NAs are in position false. Go up right there. Lillian knows. You're like, oh, You could just change that to an I right there and throw it in and go through the length of the vector and just return right there. You got it. Is this, I think, Lillian, you might have asked about this. Is this making sense here, Lillian? And then after we get done with this down here, and this is where I think Kayla said she did complete cases. That tells you if things are complete cases. So we want to go to the positions in this vector that are complete cases, because that's a logical of are they complete cases. So this was Kayla's way right here. Great job, Kayla, right there. Excellent work. Kayla's way. And then Trace, I'm going to show Trace's way right here too. Trace did it the following way, and just try it for yourself, get it to work, put those things together. Once again, you even saw I even ran the complete cases right here. Saw it tells me if things are complete cases. Then I went to the positions of the complete cases. So now we would go right here, and Trace's way was to do the NA omit. And if you look at the NA omit of the vector we're creating, it's going to throw all this stuff on here. So what we probably want to do is a two-step process. We're going to take right here and do the NA omit, and we get the following. But that's really annoying right there to have all those attributes. It's the same thing. Like if you take the sum of this vector, it's still just 1, 3. So it's 4. But if you don't want those extra things, you have to go to the attributes of what you created. This is just a second way of making your output look nice. And you need to store null, which destroys things. It's the Thanos of the world right there. Ah, Tiny Brian, go away. You go away. Oh.
You go away, regular Brian. Oh, no!
He's gone now. Okay. It just destroys everything. You're gone. That's what null does. Gone. Gone. I didn't null it out. Oh, there you go. Now it's gone. Does that make sense what's going on right here? That null destroyed the attributes. When I saved null into the attributes portion of this, gone. I can't click the button there. There we go. I'm gone now. That's what nulling things does. Gone. Destroyed. So this is just another way of doing it. I think Trace did it this way. As we say, knowing 2, 3 ways to do something is a good way to do something. It's like talking a language. A lot of these things just relate to how life is. You know, you don't learn one word in a language. Like if you're talking, you walk into a room, you're like, hi, or hello, what's up? How are you? Good to see you. Good afternoon. Good morning. Good afternoon. Good night. Let's try. What does it say? COVID store into null. It worked. We did it. We beat COVID, everyone. I wish. Oh, we beat the Delta virus. Move back to normal. I wish it was that simple. If only coding was that simple. Let's go back to the real world here. Oh, I didn't disappear. How are people doing on that question right here? Any last questions? We're going towards the end of office hours right now. Might get a call, never know. But any other questions right now? What are people wondering about? Hopefully getting a lot of practice. Go answer some Discord here in a little bit, but send in Discord, let me take a look. Discord questions. Oh, wait. For number 4, the second should be NA, but I'm not getting it. Where did I go wrong? Yeah, let me take a look. Awesome. Great job working early. Okay, the second one should be... Okay. Okay, so it's computing, it looks like. Okay. You might have hard-coded in the... If NA remove equals true, then store into NA omit the NA omitted vector. Tough question. Let me put a little music. It's a good question here, Kayla. Excellent work. Let me see if there's any. I'm going to try to figure this out while we talk about this right here. You heard about the NA. And Emily has a question here. Stats 1 noob here. I'm talking to the test, but I have issues with understanding why question 3 is 0 on the practice test for exam 2. Yeah, Emily, let's take a look at it here in a second. Thank you, Emily, for swinging by and asking a question. I will be on campus at the start of the semester. Swing by, say hey. Good to see you again, Andrew. Well, let's take a look. Emily will be working on this in 2 seconds. Thank you for swinging by. Let me see. I'm going to try to figure out Kayla's question. Okay, what I'm gonna do, Kayla, is I'm gonna take your code out of the function, and then I'm gonna store this into air quality will become X. And so what I'm doing, I wish I could show up, I just don't want to show full answers. And right now, we shouldn't be removing the NAs. Wait. What's it mad about? Oh, I don't have N stored. What is the N for this? N is 9. Sir, how on earth? How on earth what? Oh, Andrew, he's just the destroyer of everything. Andrew is just... You can't mess with Andrew Wind. He's the best. How did you not know Andrew Wind is the best? What? Why is mean able to take the mean of that? Somehow air quality ozone is getting its NAs removed. Let me run this again. This is not logically making sense right here. I think somehow... Ooh, Kayla, this is interesting. Let me sort it. Oh, the sort is removing the NAs. Why would the sort be removing... Is the sort removing the NAs? Your sort is removing the NAs. No, we'll take a look here 1 second. You could... So... Kayla, there could be an easy way of doing this. Or I'll put the code in the chat. If you just want to like do an easy way around this, like it should return NA. Just think about this, Kayla. Let's just outsmart it. If the sum of the NAs of X is not equal to 0, then we could put a return inside of here. We could just say return NA. So I think this should outsmart it. So take a look at that there in the chat there, Kayla. If the sum of the... No, wait. Sum of is NA. Sorry. Didn't have that right. If the sum of the NAs... And then Emily, we got here in 2 seconds. Emily, thank you so much for waiting. If the sum of the NAs is... there we go. If the sum of the NAs is not equal to 0, return NA. So now we run the Spannage, run it down here, and we are getting it. So I kind of tricked it right there. I'll show you on the main screen. So I kind of, I'm not going to show the full thing, though. I kind of tricked it. I used your code right here to kind of trick it with the code I just put in the chat right there. Oh, you're welcome. Thank you so much, Emily. Positivity. That's what we love right here. And thank you for swinging by and just asking a question. That's the way it goes. Hop in, ask a question, work said question. Yeah. So does that make sense, Kayla, what we've done right here? Just kind of short-circuited it from the start. I put that right after your first if. I don't want to show the full thing, but I went to your first if, and right after it said, now we're just going to end the function, if this is true right here, because the sort was removing the NAs. I kind of went through step by step to see where you lost the NAs, and then the NAs were lost with the sorting process of the vector. This depends on where you do certain things. So the sorting removes NAs because I guess it can't sort NAs, so sort removes NAs. There might be a... Yeah, I guess you wouldn't want your NAs in there if you're sorting them. Yeah, so it depends. I don't like it, though. Then what you want to do is you don't want to overwrite... Here, I can fix this. I can fix it. Okay, if you don't want to do that, if you want to don't short circuit it, you want to go and do the following. I wish I could show you. I'll put it in the Discord chat. I'm going to rewrite this here really quick. I have a way of doing it now that I just thought of. I thought of a way. I'll fix it. Oh, yeah, we're going to call this sort X. I'm changing your sorted X to be called sorted X. And then now I think your function will work. I didn't change it in the right spot. So where you saved sort X into X, I am now calling that sort X. It's no longer X. Okay, that should work. I'll post this to you in Discord. That worked. Okay. It's just that you can't use the sorted vector. So here, let me send you this, Kayla, in Discord. Here is a working version, but I saved sorted x into another thing, sort x. Oh, and I still have the, let me make sure I still have the previous. Let me run it without, so you're seeing this in Discord right now. Yeah, it works. You can remove the line where I do the remove NA, or I return NA from the start, but if you copy that out, it should work. So that should be doing that right there. Let's do Emily's question right here. I think Trace might have said something else I was hopping about. What other options there besides sort? You can sort it, but then just make your own sorted vector, because the sorted vector is going to have everything removed. And then, so that's just kind of where we're losing our NAs along the process. And so Trace is pointing out some stuff right there too. But I think you lose the NAs with that, Trace. So that's what Kayla was pointing out, because she wasn't getting the return of NA. So you can short circuit it at the start by doing the if there are NAs, just return NA. Or you could store the vector as sorted and then use that, but still divide by the original vector. And that will create the NA return, because if you divide by a vector that has an NA return, dividing by NA is missingness, because you can't divide by missingness, so you get nothing. That works right there. Awesome. Well, great job. Let's head over and look at Emily's question. Thank you so much. Here we go. Getting a little Stat 201. Did you know, Stat 201, did you know that you can actually type review 2 and it'll bring you to the review page? You're welcome, Kayla. Once again, thank you everyone for all these questions. I like when people are like, hey, I'm right here on this question. I'm getting it worked. And I'm wondering, how could I do this better? How could I do this a different way? Okay, let's put on a little chill music. And here we go. The question was, I'm talking about the test, but I have issues with understanding why question number 3 is 0. Ooh, good question. Question number 3. Well, I like this one. Emily, if you have more questions, let us know. This is a fun one. Here we go. Stat 201, question 3 about probabilities. Suppose we are considering a person driving to work on a given day. Let event C be the person gets rear-ended. Not a fun day. Oh, it's like, please don't let me get in an accident this morning. Let event D be the person gets to work without having any sort of collision. So you either get to work, and here's a key point. When we think about this question right here, we'd be saying there's 2 options really at this point. There's more. We just got 2 of them listed. We've got here that you get to work without any sort of collision, which is down here on the bottom. Let's bring it over to Word. You either get to work perfectly fine, nothing happens. We all like that. That's a good day right there. Abby, good question. We'll look at it here in a moment. Here's the probability of that. Very high probability. We like that. But then there's probability you get rear-ended. Not a fun day. So what do you notice about the idea of, and just think about this for a moment, the idea of getting to work without getting rear-ended and getting to work with getting rear-ended? Like, the yellow probability is everything's fine. You get to work. And this is you right here. You're all happy. This is you. And then this is you up here. You got to work and you got rear-ended. So because your car, someone came in and boom, hit your car from behind. Not good. What do you notice about these events to talk about them? And the way to talk about them is the following. Here is C, and here is D. C and D have no what to each other. C and D, which they don't have this, C and D have no what. Because you either get to work where you got into a rear end accident, or you get into work and you didn't get any sort of accident. These are completely what of each other. Hint, they can't overlap. They don't have any connection. These events right here are completely and utterly what? Or if you don't know, you can say you don't know. And stat 320 and 474 and 475, good review. Probability is very important in calculations. These things right here are completely hint. They're about to get a joint. Nope, don't do that. You can't occur at the same time. Disjoint. They're completely disjoint. Emily right there, 50 points, earning everyone 50 points. Great job, Emily. They are completely disjoint. Now, the weird thing is down here, we're actually asking if we can multiply these probabilities together. The and right here just stands for multiply the probabilities. Like you would think logically, well, you're just asking me to multiply these probabilities. But what is the key assumption for multiplication? The key assumption for multiplication is that things are independent of each other. And you say, Brian, you didn't say independent there. But independent means if you know one thing, it tells you nothing about the other thing. So if I say C is independent of D, if I know like C happened or didn't happen, it would tell me nothing about D. Like I always use examples like, I ate cheeseburgers last night. Does that tell me anything about my exam score? No, it's completely independent. How about studying? I studied last night. Does that give you information or help you predict what my exam score might be? Like, well, he studied, so his exam score might be higher. Then studying and exam score are not independent. So, oh, yeah, the and right there, because it's using the multiplication. And since we fail the law of independence right here, because this is interesting, because they're disjoint, if C happens, D can never, ever happen. Oh, we're always about those burgers here. If C happens, we know D didn't happen. Does that make sense? Like, when we talk about what independent means, disjoint events are very dependent. I think that even might be a random question we ask. But let's put that right here in the notes. Can we go? We're just moving that all around. Disjoint events are 100% dependent. Knowing one event happens means the other can't happen. So disjoint events are 100% dependent right there. Knowing one event happens means the other event can't happen. Like, we know someone got to work safe without any accidents. Then you can't also get to work with an accident. So this violates the law of independence right here to multiply the rule of independence, I should say. And do you have more questions, Emily? Feel free to ask. This is a good, tricky question. I remember when we asked it, and everyone's like, wait, why did you just multiply them? Said, but they're not independent. You can't multiply two things that are not independent. So knowing someone got to work safe means they did not get to work and get in an accident. So they are not independent of each other. They can't both, especially since they can't both happen at the same time, they're completely disjoint, and disjoint events are 100% dependent. Disjoint is a different thing than independent. Awesome. Emily, if you ever have those questions, let us know. Feel free to hop in here. We can work my Pearson assignments wherever you want. Stat Twins is always welcome. You know what's really interesting, Emily? Guess what we were talking about in 474 today? And they were asking, do we need to know this? 470, was it 474? 475, I think. 474. We were talking about z-scores. And they were like, do we still need to know this? And I was like, yes. And they're like, okay, what's the formula again? So if you're studying 201 and you're doing really well, these things you learn in 201, like z-scores, regression, all this stuff carries through. I've got people in both classes being like, oh, this is like this other class where we learned this. So you've got people in 474, like you could have been in there this morning, Emily, and been like, a z-score is the observation minus mean over the standard deviation. They'd be like, thanks for reminding me. I totally forgot that. The basics are what matter right here. It's all about the basics. So just keep working on those skills. Things like z-scores, rules of probability are super important, especially for market basket analysis. We're going to be doing market basket analysis very soon in 474. Literally, as these rules right here are about independence, where we assume, given like what information does this give about this, that lift, that confidence. Oh, thank you so much, Emily. We appreciate you too. You know what, Emily? I'm making Emily a mod right here. We're just going to go out on a limb. We have any rogue mods. Usually I only make people mods during class because then I know the person's in the class. I would assume you wouldn't come to a stream and be like, I'm asking a question and I'm going to pretend I'm a student. It's an excellent question. I'll go out on a limb. Well, we'll see if there's more questions. Let us know. Just checking the time, drinking the last bit of the coffee, giving out all the points. Andrew's here chilling out. Mubot's here as usual. Let's go. Let's just talk to Mubot. Mubot, you doing all right today? You doing okay?
I'm doing great, Brian. He's a good music. No.
Oh God, evil Mubot. Just having fun right here. No. Haven't been to this screen in a long time. My like radioactive screen. We're just chilling out. Last little bits of questions. Yeah, I can take some more questions. I could get a call, so I might end if I get a call. Someone might be calling. I think we're talking at 2:30. I think it's when we talked last time. But what question do you have, Kayla? Ask away. Ask away. I usually I'll go for the hour unless my teeth explode again. That was fun. But I'll go for the hour, and then especially if people have questions. I had a question. Oh yeah, Abby. Let's go grab Abby's question. In any past lecture office hours, did you ever take the time about the base structure of Shiny App? I feel like I didn't get a good grasp on the structure of the Shiny App. I'd like to understand the Shiny better. Is that right here? We did it at the start of the semester. We talked about how it works. And the biggest thing, we've got some stuff posted too. Kayla's posted a few things. Let's go grab what Kayla's posted right here and show it. Thank you so much, Kayla. Or actually, I've posted a few things. Thank you, Brian. But Kayla's been a huge help. And Kayla went through the Shiny app training. My hopes were that we could especially learn the kind of basics of Shiny with our assignments. It is a little complicated, I do know. And this is kind of like the pushing of the training of the muscle, the progressive overload of what we're learning. But also why the last group projects is not going to be a Shiny app. So I'm like, okay, we'll go pull back a little bit right here. Let's go take a look at this right here. Here we are, back on the main screen by Mubot. He's gone for now. If you go down here, we have the Shiny widget help, which is a huge page. This page I use all the time. You've also got the basics right here. So if you're going through and learning the basics of Shiny, this can really help right here. It's the basic apps Shiny you get right there. So understanding the basics right here, what the UI is doing, which is the user interface, going down here to the server. Yeah, send it to me and I'll check it out. Definitely. Awesome, Kayla. And then down here, running the app, how to run your app. This whole page right here has a lot of good basics and how to change stuff, make little changes, and how to run your app. I'd be looking through this right here, but my favorite page on this by far, and they got example Shiny apps for you to check out right here, run example reactive, run example MPG. So you've got a bunch of examples right here, an automated timer. I've never even ran this example. We can take a look at that here in a moment. But my favorite example by far, make sure my ringer's on. My favorite thing to use by far, not example in this. Silent mode on, silent mode off. My favorite example by far, my favorite thing on this page by far is the widgets. So, and I think Kayla was pointing out that also on DataCamp, they have like a whole thing with widgets. But this just shows you the possibilities right here with the date ranges, the file input, which we use in one of ours, the selection box, the sliders, the numeric inputs, the date inputs. You've got like calendar inputs right here. So all of this right here is a huge help if you have like text input, two-sided slider right here, radio buttons, like if you want to select different models, maybe, you know, like, hey, you want to do this model, this model, this model. So all of this right here, help text, if you want to throw a little help text, we're using a .rmd. It's really that the options are limitless. And that's the hardest thing about teaching this right here is I don't want to teach you how to make one. I hopefully want to pique your curiosity and give you something to like sink your teeth into. Does that make sense, Abby? The hardest thing about this is not like we're all going to make the same thing. Everyone's going to make slightly different things. It's all going to achieve a very similar goal. And then we hopefully gather some skill sets and we're creating something we can use for the future. I've gone through this right here and done display reactive output, and Kayla was posting a lot of this too. Use R scripts. I mean, you look at what you can create right here with Shiny apps, with what they're showing. Pretty cool. The census visualization right here, just nice, kind of neat. And they walk through how to do it. So please start early. According to DataCamp, you can run a Shiny widgets gallery in R, and it creates a Shiny app of widgets. Yeah, that's what Kayla was saying. Let's go do that here real quick. So we need to make sure we have library Shiny going. And I've got library Shiny JavaScript also. And so we should see Shiny widgets. So I think it's the Shiny widgets package or library, Shiny widgets package and library, same thing. And so Kayla's saying run the Shiny widgets. So there's no package called Shiny widgets dashboard. Thank you, Kayla, so much for all the extra posting and everything. Okay, it's liking it. Here we go. Oh my gosh, this is absolutely insane. Wow. Talk about just beautiful. Kayla, 100 points. I can't think of something. I mean, this is what I would say is a professional Shiny app right here. Awesome checkbox and radios. Wow. Wow. This is just beautiful. This is what we're capable of doing right here. Icon in the middle. If you look at all the show the code for it. Oh my gosh, look what they got for you right here. This, I need to mark this because this right here, I mean, come on, free code. They're like, you want to make this? You want to throw this in? You want a little thumbs up icon in here? There you go. You want a little mini button? Little mini button? There you go. There's the mini button. Size equals mini. Just an argument added on right there. Input ID right there. ID. So that's where it's going to be registered in your input. So can anyone call this as though you want to get what someone put in here for the on-off selection? So this is taking a true false, and that's what will be stored into here. Who knows how to obtain this in your server? Who knows how to attain this in your server? Which is what we've hopefully been learning along the way here. How to obtain this in your server. Very big question. This is being stored somewhere. How would you obtain that value right there? You don't have to use that input ID. They're just going through, it looks like this is their 16th thing they've created. So ID 016. I'd probably call it something a little bit different. Like maybe, I don't know, like transformation if you're transforming it. So where would you call to get this? So you're down here in the server now. You got your user interface up here. Now you're down here in the server portion. Yes, exactly. Kayla's right with globally. And so, Kayla, if you want to write in the chat real quick, just to make sure people know, and I'm 100% sure Kayla knows what I want. I want a little, money. So where are we going to go to get that? So I think I'll put the answer in chat here in a moment if people don't know. Yeah, exactly. So this is absolutely astounding. Kayla well earning everyone another 100 points. And I might even show this in class tomorrow because the availability to just go and grab this code. I mean, you've got multi JavaScript, right? What? This is insanity. I mean, what? This is... I just don't even know why I'd use this, but I just love it. I guess you can go grab your own icons. Let's go look at the code for this. So there's the input ID, label countries. That's just the label. And because we should see up here countries, there goes the label. Choices equaled null. They don't have any choices selected. Choice names, L apply. So I think countries is a vector currently stored inside of R. Let's go find that countries vector. Where's again that countries vector? Oh, it's mad. Okay. Where is it getting that vector from? I got to run it again to find that vector. I am just blown away. Let me see the code again. Sequence along, L apply. So right here, for me, the server side of things and converting inputs and always confusing me, like how to put in the variables from the input data as choices on the side panel. So, and message me with where you're at and where you're stuck, and I can help along the way. Yeah, and the biggest thing is just starting out small. I know that a lot is going on right here. I'm wondering where it's getting it from. Tags, images. They might have already loaded this into their environment. It looks like they have a vector right here. Tag list, tags, images. Okay, cool. That's complex. Awesome radio buttons. Oh my gosh, so cool. This, you could take this. That's not that crazy. When I saw this, I'm like, that's not that crazy, but that's really nice radio buttons right here. Status warning. I think that's how their color choices are going. They're starting it off with B, and they're just going to radio with status. So you've got so many progress bar. Just, gosh, I didn't even know all this was capable. I'm literally blown away by this. I just want to click every button. Drop downs, sweat alert. What? I have never seen Shinies do this. To point out, Kayla, to show people what Shiny apps are capable of, Kayla posted something a while ago. Here, Kayla, message me again in the main chat or in the DM. But Kayla posted something in 475 a while ago. Or was it Kayla? I think it was. I'm going to have to find it. But Kayla posted a Pokemon app. We've been very active. That's awesome. And here it is right here. Let me load it up. So this is the Pokemon app to show you the extent to which things are capable of. It really is absolutely limitless because you're about to see what a Shiny app can do right here. Literally, and it should be showing the picture of the Pokemon. I think it's still loading in the background. Like, you're seeing all this is being done with a Shiny app right here. So we can go to Poke List and get all the Pokemon. They might be doing something similar to the flag thing right here. You know, you've got a slider. You start to break this down. I think this would be based on the flag code. Does that make sense to everybody here? You got, look, it's so cool. You can see all your Pokemon from a certain Pokemon forward. Like, that's kind of simple. You got the Pokemon attacks right here. You can see pound and just look at the different attacks and see like a matrix of how good it is. Poke Network, kind of interesting. You can change the size. Here's all the network options, change all the nodes and the size. Circles versus, yeah, now it doesn't show the Pokemon. Pokefight actually lets you fight Pokemon. I have no idea how they did that. And then Poke Other, just absolute insanity. Generally speaking, the UI, you assign inputs with the input ID and you can access them with the exactly. Kayla, thank you so much. Let me throw another 20 points. Abby, please message me whatever you're stuck on. And Kayla's pointing out right there that whenever you create something in the UI, it'll go into kind of the global environment as the input, and then we can access it down later on in the server as the input $sign. Does that make sense, Abby? So down in the server later on, we can grab that value later on. You know what? We got enough time here. I think my call's at 2:30. Let's try to create a really quick app right here. So all we're going to do is let's try to do something. Let's do really simple here. Really specific. Let's do something really small, really simple. Always start small. Let's see what we got. So what we're going to do right here, so we're just going to pull up the Shiny Basics. Let's go to Shiny Web App. I always like it. Let's call it random. Random 2. Probably got a bunch of randoms. We can delete off all their extra stuff inside of here. They're going to give you a few of the basics thing right here. You've got a title panel and all this good stuff. And you've got a slider input. So when you think about this right here, do not go in too many steps. One, I'm going to make sure everything I have here works. Just do that. Does it work? Let's see. It works. So we're not working with this app specifically. We're just working with this right now. But let's say we want to work with this app right here, and we want to change this not to a slider input, but maybe a numeric input. Does that make sense? So we got to be careful because we're about to destroy it. But here's where the slider input is. Does this make sense? The slider input is going to store whatever we put into the slider as the object bins. This is just the idea of it. So down here later on in the server, you will see where bin is being used. Down here, somebody is getting the input from the UI. And then this server is going to do the actions right here and render a plot based on this. And then this needs to be sent where? So I'm going to repeat the process, and then I want to think what happens. Somebody up here is going to tell us how many bins they want. That's the UI where we see it visually. Then it gets sent down to the server where computations are happening, and it's going to render a plot, and the server's just doing this in its brain. And then where does this need to go? So Kayla's pointing this out right here. So where does this need to go now that we're down here in the server doing all the computations? Kayla, amazing work. And so where does this need to go now? Because the computer just did a bunch of work. It created a plot for us. It says, here's your plot. So this is where it's being stored into the output list, which Kayla's pointing out right there. So we've created something of an output. So now where does this need to go? Hint, we need to see it. So where does this need to go that has been created down here? Where should that go? So remember, I'll repeat the process again. Somebody input a bin for us. That was that slider thing we saw. And then that bin they input is going to go down here as part of the computations, and we can grab it. We can find what they input. That's going to take their input for us so we can see what they input. And then we're going to use this to figure out how many bins to put in that histogram. We're going to create that histogram, and then we're going to send that where. So now we've just got a histogram in the computer. But you can't see it yet as a hint. So the computer's made a histogram. Where does that need to go? Any ideas? I'd like to go with the answer. It needs to go back up to the UI. The UI is where you see everything. It's the user interface. Well, it's stored to the global environment, but we need to bring it back up to the UI. So does that make sense right here? It's currently stored to the output, it's stored to this value, but then we need to bring that back up here with the plot output. Does that make perfect sense? Like we bring it back up. We're no longer in this, I think Kayla knows this, we're no longer in the server portion. We're bringing it back up because we had someone input something right here. We went down to the computer portion of it, which is the server. It ran a bunch of stuff for us, and then we bring it back up here to the UI. So you're not seeing the server portion of this. You're inputting a value here, and I wish it would not change it. The computer down here is doing output and then throwing it back up. It's like input value, computer does work, but then you have to go grab that value and bring whatever the computer did and bring it back up here. So it's a process of you input something, the computer does some stuff, and then you have to display that or bring out the output. You have to show it somehow. And so we can get that right here. And so we can change this. Let's go grab one of those cool input things. Let's go find it. We've got it over here. Let's go change this to something way cooler. Let's go grab one of their cool things. So let's see right here, switch inputs. We want like a numeric input. Does it not have anything cool for numerics? Switch input. I'm gonna see if they have any cool. Click me. Everything says click me. So I might pick one of these and do something with it. Okay. Go right here. Okay. I'm going to grab this code right here, and I'm going to make it so it changes colors of the histogram. So I'm grabbing this code right here, which will add radio buttons. The first thing I usually do with this radio button right here is I'm just going to add it into my Shiny app. I love this, Kayla. I love what you found. It's absolutely amazing. So we're going to go right here. Okay, we're inside the side panel right here. Okay, so we're inside our side panel. You can tell, especially by the indentation. Let's make sure we haven't broken anything. Watch it break. Cool. This is step one. This is important steps for 475. This is step one. Does everyone see how I went, got that code, put it in here? Code is working. Does this make perfect sense? Does this make perfect sense? Like, I think Kayla's getting it. I went to the Shiny widget thing, which you saw earlier. I have to go, yeah, awesome. I'll continue to sound right here. And then now look at the Discord. Throw me another message on Discord so it'll reblink because I was on your message and I hopped off to another thing. But just be like, hi, and then I'll check it out. Or else I might forget. So with this right here, we've added in just this. And we just took that code, tossed it right in, put it in the right spot. Boom, we got buttons. Now we got buttons right here, but the buttons don't do anything. They're not sending anything to the server right now. Let's get it to send something to the server. So if you notice right here, we've got an input ID. So whatever is put into here will take on these choices right here. This is what it says for label. I'm going to change label to color, but you can't guess what I'm going to do with this. So with this, I'm compiling a list of question problems. Yes, sending me on Discord soon. Awesome. You know what I'm going to do right here, though? I'm going to run my app again. And guess what? Color. Awesome. So now let's go to choices. Red, blue, green. Run the app again. I'm not joking on how many times you should run stuff. Whoa. It's not doing what I want, though. Remember, I've been running it every time I change something just to make sure. Now, I knew that was, I didn't know, but I had a good feeling that it would work. It's very easy to break things. Very easy to break things. Always run your code. Small changes, always run your code. I'll probably break something in a second. Now, where is this being stored? It's being stored under input and this value right here. I don't like it being called that. I'm going to call it hist color. I don't want it to be called this. Once again, this won't break anything. It's just whatever I put inside of here in the brain or the server side of it is being called hist color. So that means when I go down here, I need to use a similar call for it. I need to go down here to the histogram and the way it's being colored, like we did for input bins, and go right here and go to, it should like it, cross your fingers, hist color. Run the code, breaks. Nope, doesn't break. Red, blue, green. These are the small changes I'm talking about now, and look at how much we've changed through this. Look at how we were able to add buttons, but we did it in little steps. We added the button. Then we connected it down to the server. Then we made sure the server is retrieving the output. Is this making you feel a little bit better, Abby? I hope this is helping with kind of how things work, with the process of maybe just creating a button, making sure that output is captured down below, knowing where that output is being transferred through the process, and just seeing, there's near limitless options. I just went, and thank you so much, Kayla, right there. Huge help on this. I just went to the Shiny Widgets gallery and said, you know what? I like these buttons. So this right here is ridiculous help. This right here is so awesome with all the buttons and options you have. You could go right here and change this right here to true or false. And so we can obtain a true or false value from this. So I'm trying to think what we could do true or false on our histogram, but yeah, label in the middle. They just got so many endless options. All of these things right here, picker input. So you could select right here a color. So we could change this right here from just a multi-choice button to a picker input right here, which will pick. There's a placeholder. So now they've got a default placeholder, which actually goes away. Very interesting. They've got icons right here. All of this code can be done. Yeah, so check this out. Some of it gets really complicated. So you might be like, I'd just like a drop-down menu right here. So let's just do one more. I got enough time. I might get a call, so I might have to go. So we just took this picker input right here. We're just going to do the same process once again. We're going to go right here, and we're going to make sure we're in our side panel at this moment. The side panel ends right here. So this is inside of the side panel. How do I know this? Well, you can do this. This might help with seeing it. I might have to zoom out just a little bit here. We are inside of our side panel because the side panel closes. Look at when we go the closure here. Once again, I'm going to run this. I don't see any reason why it should break, but you never know. You might break things. If you notice, we now have a picker input below here to pick different things. So now we need some options right here, maybe on colors for the border. We're just going to do the same process. The picker input is this ID, let's say border color. And the border color, we could go here, do the same things. We could just go black or white. Nice and easy. And now we only have two options in here. And the picker input is border ID. So we need to go down here to the border and change the border to input whatever someone put in the border color. I did a lot of changes. Got to watch out. But we've done it. We have done it. We can go from a black border to a white border pretty easily for our histogram. And yeah, it's all being done interchangeably for us. These are just some of the smaller options, but are you feeling a little more comfortable here, Abby, seeing this maybe? I definitely think maybe I should make an assignment next semester that goes over this, like the basics of Shiny. I could see putting this in. Please give your inputs about how you feel, where you got lost. I know a little bit it was like you teach yourself, but maybe I could do something like this right here, where I say, make a Shiny app that allows you to change the color of a histogram's border. Hey, what's up, our Bulgarian friend? Good to see you here. It's almost the end of office hours. Have you used much Shiny? We were just working on making some basic Shiny apps right here, changing widgets. We're just using the default Shiny app and just changing some widgets, working on some stuff. Mubarak's got some awesome stuff. This website has more than... Is that what you got your icons from? Awesome font right there. Let me pin that. Mubarak said, "You're so shiny today." I got new teeth today. I got a new tooth today. I think that's got it. I'm going to call someone here. It's the end of office hours. Good seeing everybody. With that, it's time to end class. End office hours. What are we talking about? Mubot.
I am Mubot. Woo!
Bye for now, everybody. We'll be back next time on Stat 201. Keep working on those apps.
Great work, everybody.